Well, hello there. This is a terrible dubbing of this video. I forgot to turn on my mic. This is 8.2 about hyperbolas. And hyperbolas are going to be a lot like ellipses, just that we have a minus instead of a plus. And this time, instead of a being your biggest number, your a is always the number that's being subtracted from. So if you look at that top example, the a is under your x because that's being subtracted, or like the y is being subtracted from your x. On the bottom one, A is underneath your Y because that's the one that's coming first. Also notice which way they open up. If X comes first, it opens up left to right and right. And if Y is first, it opens up top and bottom. Yeah, there. I'm talking about it right now. All right, so why did I erase that with my hand? That's gross. I point at some kid. All right, so this next slide is going to be really important. It has all the major formulas on it. Make sure you have those. Your transverse axis is 2a. Your conjugate's 2b. Now your vertices are going to be on your transverse axis. So if x is first, your vertices are on that x-axis. If y is first, they're going to be on the y-axis. You also have asymptotes, which are going to be a slope times x because they kind of go diagonally. All right, and there's eccentricity with c over a. Again, we're still going to do our a squared plus b squared equals c squared. That's slightly different than ellipses. So make sure to keep that in the top of your mind as we're going through and doing this. Okay. So that problem. All right, let's get to work now. So now with these, we're going to find a bunch of different things about our vertices, our foci, our length, transverse axis, our length of conjugate axis, our distance between foci, asymptotes, eccentricity. Now it's like Jackson 5 once said, it's as easy as 1, 2, 3, A, B, C. So once you find your A and your B and your C, just go back and we're going to plug them into all those formulas we have from before. So we're going to start with our A squared and our B squared. Well, our A squared is under our X squared because that's the term that's coming first for this hyperbola. And our B squared is under our Y squared because that's the term that came in second. So our A squared is 16 and our B squared is 81. All right. Now from there, we can find A by square rooting it, getting 4. We can find B by square rooting it and getting our 9. It's like I'm there. Look at it. You didn't even know that I'm recording this in a different room in my house 10 hours later. All right. Now for hyperbolas, c squared equals a squared plus b squared. Ellipses you subtracted, but for hyperbolas, you add them. Good old Pythagorean theorem I'm probably talking about. Probably just said a joke there. Everyone laughed. You can tell. Ha 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 ha. All right, let's get serious now. So c squared is going to be our 16 plus our 81. I'm going to leave this answer square root. Remember on your Moodle, make sure you round to the appropriate place. Okay. So I get c is square root 97. All right. So, all right. So now we have our A, B, and our C. And now we're just going to start plugging and chugging along on our different formulas. So the thing we're going to start with first is finding our vertices. Now, because x is first, our vertices are going to open up to the left and right. And they're going to be on the x-axis because that's where our center of our graph is. So for our vertices, think about, yep, that's a great drawing. It's okay. Now our A is 4. So each one of those vertices is going to be 4 away from the y-axis, right? 4 to the left and 4 to the right. That was just me saying if y came first, it'd open up and down. All right. So that point's 4, 0. And the point to the left is negative 4, 0. And I look confused and I throw something in sync and I show you a cool picture, a handoff hyperbolas. I should probably post that for you guys. If I remember to, email me. If you're watching this and I have not emailed this out to you, please send me an email. I will post it. It's a very handy thing. All right. Here I'm rewriting our -4 and our 4, 0. All right. Now, next thing I'm going to do is probably find the transverse. So the transverse distance is 2a. And here, a was 4. So I'm going to do 2 times 4 is 8. Next is the conjugate axis. Now that one is 2b. Our b was 9, so 2 times 9 is 18. Yep. Again, once I find A, B, and C, you just start plugging it in. I made another funny joke there, and I pointed to the sky. Also, my hair is getting quite gray. Yipers. Father times undefeated, y'all. Now, distance between foci is maybe what I'm going to do next. We'll see. We'll see if I can find out what I'm going to do next. Who knows in this wild world? All right, now the foci. Oh, no, asymptote. So that's going to be our plus y equals plus or minus 9 over 4, or b over our a. There's 2 asymptotes. All right, I should probably try to find the foci next. Yep, here I just realized. Oopsie doodles. So the foci are going to be on the x-axis, and the distance between foci is going to be 2c. We're using our c for our foci, right? So square root 97 is where our foci coordinates are going to be. And I did 2 times square root 97, find the distance between foci, and find the actual foci. It should be negative root. Here it is. Negative root 97, 0, and square root 97, 0. Again, they're on the x-axis because x came first in this equation. And lastly, I'll find the eccentricity. The eccentricity, eccentricity. Uh-oh, hope you didn't hear that. Is c over a. Here our c is square root 97, and our a is 4. All right. If you guys want to on this next problem, try to pause it. And you can try this yourself and then check it with mine as you go through it. Okay. So we're going to have another example of this. You can pause it and try it and see how you do. Well, that took a long time to erase. But yeah, pause it, try it, see what I do. All right, a squared to b squared. And this time our a squared is under a y. So a squared is going to be 25. B squared is going to be 9. Also, it's going to open up and down because, well, the y. All right. So again, know which way they open up. So a squared is 25. So a would be 5, square root both sides. B squared is 9. Square root both sides and get b is 9. Or 3. Oopsie doodles. So here I'm going to do c squared equals a squared plus b squared. All right, so c squared is 25 plus 9. C squared is 34. So c is square root of 34. Again, use decimals if you're doing the Moodle thing. And once you have your A, B, and C, this isn't so bad, okay? All right, so vertices now are going to be on the y-axis because y came first. Up 5 from the origin, down 5. So I get the point 0, 5, and 0, negative 5. All right, pretty soon I'm going to check my mic. Now your focus on these ones is actually inside those cups. It's going to be a little bit further away. And use that square root thing. So I'm going to use square root or 0, square root of 34, and 0 square root or negative square root of 34. Okay. And I think here pretty soon the sound's going to kick back on. Let me check. My mic was off the whole time. I'll have to go back and dub this video. Well, welcome back, people. All right. A, C, and C for my foci. All right. So now what do I need to find? What's my transverse length? Isn't it 2A? So that's 2 times 5. What's my conjugate? Focus. My conjugate is 2 times B, which is 2 times 3, which is 6. All right, any questions on those that we found so far? Once I have my A, B, and C, I'm just plugging and chugging. So what's my foci distance between foci? It's 2 times C. So it's 2 times square root of 34. Where are my asymptotes? Pay attention to this one. Don't make an asymptote of yourself. That's plus or minus C over A. So it's plus or minus square root of 34 over 5. Am I missing? Is that everything? That's a pretty good start. That's a lot. No, absolutely not. Yeah, it's fat cat in it. That's the next one's gonna be a lot quicker. What about we're gonna skip this one if you guys are okay with it. If you like to see it, you can always watch Dr. Webster's video. What? It'll be on the video. Guy's coloring a turkey. I'll screenshot it. All right. Let's do this one. This will be a quicker one. We're not finding all the features, we're finding one feature. This one, the next one. We got 5 more minutes. All right. Transverse axis has a length of 10. Conjugate axis has a length of 16. What's my equation for transverse axis? 2A. Conjugate is 2B. So what's A? What do we always have to find? A and B. If 2A is 10, what's A got to be? 5. If 2B is 16, what's B got to be? 8. Now, they want the distance between foci. So what letter gives us foci? C. It's in the word. So for hyperbolas, it's a squared plus b squared equals c squared. All right, it's go time. 5 squared plus 8 squared equals c squared. I'll get out of the way. So I got 89 is c squared. So square root of 89 is c. Now that gives me the foci. How do I find the distance between foci? That's 2c. So that's 2 times square root of 89. That's it. Once you find c, you times it by 2. All right. One more. If you want to learn more about conic sections, take pre-calc. You'll see them again. All right. This time we're going to write the equation. We're going to write the equation. So the equation of a hyperbola. All right. The conjugate is along the x-axis. If the conjugate's along the x-axis, it means it's going to open up like this. Okay? If it opens up like that, what comes first, x or y? Y. So this equation is going to be y squared over a squared minus x squared over b squared equals 1. Now, the conjugate axis has a length of 14. Conjugate is 2b. The transverse is 32. That's 2a, right? Transverse is your a, conjugate is your b. So 2b is 14. 2a is 32. What's a and b? A would be 16. B would be 7. Divide both sides by 2. Is that enough information just to plug into that wicked beast up there? Yeah. So I get y squared over 16 squared minus x squared over b squared equals 1 squared. Bless you. So it's that y squared over 256 minus x squared minus 49 equals 1. Yeah. And that's all I have for today. All right.